Wow, wow, wow. Today we're going to see the difference between junior code and senior code. And hopefully, by the end of this video, you'll pick up some useful knowledge. All right, enough talking. Let's get started. Let's start with our first example. Now, take a look at this piece of junior level code. This is a very typical way a junior developer would write code. First of all, we have to say that this code is not wrong at all. The author checks whether the user exists before accessing user.name, which helps prevent runtime errors, a very common mistake for beginners in JavaScript. Besides that, the logic of the function is quite easy to understand. If there is a user and the user has a name, it returns the name. Otherwise, it returns a default value, which is guessed. This is a safe approach and works well for small projects, or when you're just getting started with programming. However, when we look at this code from a senior developer's perspective, we start to notice some limitations. First, the logic is a bit too long for such a simple task. We're just trying to read a value and apply a default, but we already need an if-else statement. As the number of cases grows, this can make the code more verbose than necessary. Second, the condition user and user.name is a fairly old pattern. In a large code base, patterns like this tend to appear everywhere, which can make the code harder to read and harder to maintain over time. Finally, this code doesn't take advantage of modern JavaScript features. So in the long run, it's not optimal for scalability and reusability. To sum it up, this is a piece of code that is correct, safe, and easy to understand for beginners. But it also shows the limitations of a junior mindset as the project becomes more complex. So, how would a senior developer approach this problem? The requirement stays exactly the same, but the way the code is written is completely different. Now, let's see how a senior developer would handle it. Now, let's take a look at the senior version of this code. The first thing you'll notice is that it's much shorter, while still keeping the exact same requirement. Here, the senior developer uses optional chaining to safely access the name property without risking a runtime error when user is undefined or null. Next, we have the nullish coalescing operator. This allows us to provide a default value, guessed, only when user.name is null or undefined. The key point here is not just that the code is shorter, but that its intent is immediately clear. From a single line, you can understand exactly what the function does, without reading extra conditional logic. This is how a senior developer thinks, writing code that is readable, maintainable, and fully leverages modern JavaScript features. In other words, senior developers don't try to make things more complex. They make things simpler, but correct and safe. I hope the previous example gave you a bit more insight into a senior developer's way of thinking, and to better understand the difference between junior and senior code. Let's move on to the next example, where this gap becomes even more obvious. Next, let's take a look at the junior version of this solution. This is a very common approach and something you'll see a lot in beginner projects. First of all, it's important to say that this code is logically correct. The function iterates over the user's array, checks whether each user is active, and if so, pushes the user's name into the result array. For beginners, this style feels very safe. Everything is explicitly controlled: the for loop, the if condition, and the manual push into a new array. Another advantage is that this code is easy to debug. When something goes wrong, a junior developer can step through each iteration, inspect the data, and understand exactly what happens at every step. However, from a senior developer's point of view, several limitations start to appear. First, the code is quite verbose for such a simple task. We're just filtering data and extracting a single property. Yet we need multiple lines of code, temporary variables, and control flow statements. Second, this approach focuses heavily on how to loop, rather than what the data represents. As a reader, you need to scan through the entire function to understand that the real goal is to get the names of active users. Finally, as the logic grows, for example, when more conditions are added, this function can quickly become longer, harder to read, and harder to maintain. Now, let's move on to the senior version. At first glance, the code is much shorter, but the real value here isn't the number of lines. It's how clearly the intent of the code is expressed. The senior developer uses array methods like filter and map. Filter clearly states the intention. We only care about users who are active. Then map defines the next step precisely, extracting the name property from each filtered user. This approach reads almost like a sentence. Filter active users, then map them to their names. In addition, this style makes the code much easier to extend. If we need to add more conditions or more processing steps later, we can simply chain another method without breaking the existing structure. From a maintainability perspective, this code is easier to test, easier to refactor, and much better suited for large-scale projects. This is the core difference between junior and senior developers. Seniors don't just write code to solve the problem today. They write code with the future in mind. In the previous example, we saw the difference in how junior and senior developers handle data. Juniors focus on the mechanics of looping, while seniors focus on the meaning and flow of the data. But the senior mindset doesn't stop at array manipulation. It becomes even more obvious when dealing with business logic and validation. And that brings us to the next example. In this next example, we're looking at something every project has to deal with: user input validation. This junior-level code uses multiple if statements to check each condition one by one, returning false as soon as something is invalid. First of all, the code works correctly. It checks whether the user exists, whether the name and email are present, and whether the email matches a basic format. For junior developers, this approach feels safe and straightforward. The logic is easy to follow from top to bottom. However, when we look closer, several issues start to appear. The logic is repetitive. Adding new validation rules means adding more if statements. More importantly, the function doesn't explain why validation failed. It only returns true or false, which makes it harder to show meaningful error messages in the UI. As the number of fields grows, this function becomes longer, harder to read, and difficult to maintain. Now, let's look at how a senior developer approaches this problem. Instead of returning just true or false, the function returns an object that contains detailed validation results. This might look like a small change at first, but in real projects, this design decision makes a huge difference. By returning more information, the UI or the business logic can clearly understand not only that something went wrong, but exactly what went wrong. This allows the application to display meaningful and precise error messages to the user, rather than a generic "something went wrong" message. As a result, the user experience becomes better and the code becomes easier to reason about. Another important point is how the validation rules are structured. Each rule has a clear responsibility, making the logic easier to read and easier to follow. When new requirements come in, for example, adding more fields or new validation rules, the code can be extended without rewriting the existing logic. This structure also makes the function much easier to test. Each validation case can be tested independently, which is extremely important in larger applications. And this brings us to the key mindset shift. Senior developers don't just validate data to make the feature work today. They design code with clarity in mind, with scalability in mind, and with long-term maintainability in mind. In other words, senior developers write code not only for the computer, but for the people who will read, use, and maintain that code in the future. Through the examples we've just seen, I hope you can see that the difference between junior code and senior code is not about fancy syntax, but about mindset. Junior code usually focuses on making the code work. Senior code, on the other hand, focuses on making the code easy to read, easy to extend, and easy to maintain in the future. If you're still a junior today, that's completely okay. Everyone starts there. What really matters is that after each example, we gain a little more insight into the senior mindset and gradually improve the way we write code. In the coming videos, I'll continue sharing more real-world examples, directly comparing junior approaches with senior-level thinking, so you can apply them right away in your own projects. I hope that after this video, you've learned at least one thing that gives you a more senior mindset. If you found this video helpful, don't forget to like, share, and subscribe to the channel so you don't miss the next examples. Thanks for watching until the end, and I'll see you in the next videos.